All right, well, thank you everyone for joining us for our 67th webinar in the American Trails Advancing Trails webinar series. My name is Candace Gallagher, and I am the Director of Operations and Webinar Coordinator for American Trails. And before we get started, I did want to go over a few logistics and reminders. The webinar presentation will run approximately 75 minutes, and at the end, we will have a Q&A that will run until approximately 30 minutes past the hour. Please send us your questions via the questions box in your control panel at any time during the presentation. We will add all of them to our website within a couple weeks after the webinar, and we'll try to get to as many as we can during the live presentation. The webinar is being recorded, and a link will be sent to all attendees within a few days, along with the closing slide and the presenter partner slide in PDF format with clickable links. We do offer multilingual closed captioning in over 100 languages for our webinars. And for today's webinar, we are offering complimentary closed captioning in English. And we will post that link to view the closed caption in the chat box momentarily. And if you are ever in need of another language, please let us know. And finally, a variety of learning credits are available for this webinar, and they are included in the registration fee. Please contact me if you would like more information on that. And a big thank you to the partners of today's webinar, which include the U.S. Department of Transportation, Federal Highway Administration, the National Park Service, U.S. Fish and Wildlife Service, the U.S. Forest Service, the Bureau of Land Management, as well as today's presenters, whom I will recognize in just a few minutes. And today's webinar is titled Designing Near Wetlands, Streams, Forests, and Other Environmental Resources. This presentation will discuss the 7 biggest considerations for planners and designers when designing in these sensitive areas. And this was also a presentation at our International Trails Symposium in this past April in Syracuse, New York, and it was very well received. Our first presenter that we have is Daniel Biggs, who is a registered landscape architect with over 15 years of multidisciplinary experience in all phases of landscape architecture design and environmental planning projects. And Daniel is currently the regional manager of Weston and Sampson, which is based out of Albany, New York. And our second and final presenter we have is Jason Philbin, who is the president of Permatrack North America, which is a concrete boardwalk design build company. And prior to Permatrack, Jason was a director of pre-construction and area engineer for multiple geotechnical contractors and pre-engineered bridge manufacturers. I am excited to get started with today's presentation, and I am going to be passing the controls over to Daniel to get started.
Thank you, Candace. Welcome everyone to today's webinar on design near wetlands, streams, forests, and other environmental resources. I am Dan Biggs from Weston Sampson in Albany, and joined by Jason Philbin of Permatrack in Charlotte, North Carolina. First, a little about us and our firms. Weston Sampson is a multidisciplinary planning and design firm along the eastern seaboard from Maine to Florida. We have a staff of more than 600 professionals in various programs from survey and mapping, master planning, environmental permitting, landscape architecture, civil site engineering, and construction phase services. Permatrack North America is a premier provider of environmentally friendly precast concrete boardwalk and elevated greenway solutions. Permatrack was actually started in Australia in 1996, and since then has expanded to the United Emirates and United States. Jason leads a team out of the Charlotte office with over 4 or 5 people, and they actually manufacture in 3 states and growing. To date, they have over 220 structures installed in 25 states since 2010. So first, we want to briefly go over some objectives for today's presentation. We hope at the end of this webinar, you'll have a better understanding on how to identify and plan within and around environmental resources. We hope you have a better understanding on the potential solutions when designing with environmental resources. And third, learn about how multifaceted approach to plan designing of trails with environmental resources can be implemented in any community for various types of recreational resource plans and projects. Really quickly, we want to get a poll to see who's in attendance today. Well, it looks like we have a pretty good attendance today, with the majority being in the public sector and a third of you all being in the private sector. And our next poll. So next you want to find out, what is your role in the design process? Are you a contractor, a designer, an owner, or a supplier?
And what we mean by a supplier would be somebody like Permatrack in North America that you're not, maybe you're supplying a railing or a boardwalk or a foundation system. You probably know which one you fall into. They're one of the four that you see on the screen.
Looks pretty good. We got actually a large number of designers here in attendance and some owners and suppliers. A few contractors out there, but we think we have information that we can share with you all of interest. So let's just get started. So today's webinar, we're going to cover a couple key points. The first is to help you identify types of users and facilities. Second, we're going to run through 7 design considerations around resources. Third, we'll identify strategies and solutions when working in and around environmental resources. And then we wanted to follow up with a couple case studies just to give you real world examples on how we have solved on various projects working with resources in and around them. And then we'll have time for questions and answers at the end. So first, it's important to understand who you're planning and designing for. Users can come in a variety of needs, interests, and it's really critical to know who are you trying to serve. Users can range from bicyclists who are looking to get from point A to point B as fast as possible, while others are looking to ride for a family ride side by side, or just enjoyable experience through environmental area. Users can come in a variety of ages and interests as well, from runners hosting a outdoor running event, or simply having a local trail connection through a park for families and relatively low impact users. So with both of this, it's important to know what is the volume, what is the means that people are going to use this facility, as well as what is the context for where the trail would extend through and around the various resources. And these are all important as you work through the planning design process. So the context of a trail facility sets the stage for how you're going to work in around different resources. The example on the top left is a typical multi-use path. This project is what most think of serves a variety of users. Asphalt surface, hard surface, spanning a resource. In this case, it was a stream. It really allows users of all needs, whether it's a rollerblader or a bicyclist, to a runner and a walker with a stroller, to get through this area and to cross this resource. In contrast, the users on the right-hand side, a little more rugged riders, a single track through a mountain area, they would require a different means of crossing a wetland stream or a resource in the area. So overall, it's important to understand who are you serving and how are you getting through these resource areas. So real quickly, a few of the basic trail facility types. The first, which is likely most familiar to many people, are multi-use pathways. These typically range from 8 to 10 feet in width. Sometimes they do get larger or wider as the need and demand within a resource area is shown. Typically have a hard surface. In many parts of the country, this would be asphalt, concrete, or other suitable surfaces. And they serve a wide variety of users: walkers, bicyclists, runners, and most types of users. These facilities support a wide range of wheeled users, whether it's rollerbladers, scooters, or even some strollers. The ATO bike guide is a good guide to follow when looking at designing these types of facilities. Soft surface trails, these can vary considerably. They vary in width from 6 to 8 feet wide or smaller, depending on the demand. They can consist of a variety of surface materials, whether it's stone dust, mulch, or other soft surfaces that are regionally context sensitive. And they serve a variety of users: walkers, bikers, mountain bikers, runners, or dog walkers. And as the surface changes, it tends to enable some users to not desire to want to use these facilities. So you'd likely not see a narrow tired bicyclist. You may see more knobby or hybrid style bikes in these conditions. Bridle paths, these are typically soft surface pathways for equestrian riders. Range from 8 feet in width, sometimes less if you have a single track alignment for riders. What's critical of these pathways is a vertical clearance to enable riders to get through a vegetated area. And typically beyond bridle paths serving equestrian riders, they serve mountain bikers, runners, and dog walkers. The various uses within these contexts for different users, it comes down to the potential conflicts and the scare that could happen to horses as different users use these facilities. So signage is important for bridle pathways. Single tracks, these are the most narrow pathways in general, 2 to 4 feet wide. Natural surfaces, they can have a very light impact onto the ground, onto the surface. The International Mountain Biking Association has a great resource for planning design these facilities in a sustainable manner. These facilities also support hikers, trail runners, and occasional equestrian riders. So real quickly, some of the characteristics of trails we want to cover that are important. The first is trail width. So ensure width to enable users or the interested parties to get through the corridor or the alignment of the pathway. Shoulders and shy zones. So those are areas on each side of the pathway, ensuring they have proper clearances for safety and getting through the resource area. And finally, the trail surface. As I noted previously, there's various surfaces out there that can be used on pathways. So ensuring that you have the correct surface for the intended users and user types that are going to use this facility. And this is most important as you have a pathway approaching a resource area when you're considering a boardwalk, a bridge, or other means of crossing or going around a resource. So as we continue to talk about the different types of facilities, you'll see that this pathway width is important to keep users through and around the resource areas. So 7 design considerations that we believe should be considered for trail facilities. Starting with identifying the resources and the potential regulatory requirements. Second is looking at the site considerations. Understanding the context of the site is really important to know how is it most appropriate to connect in and around the resource areas. This results in the potential regulatory requirements of working through the permitting process and making sure that you're compliant with local and federal requirements for permits. I'm establishing the structure footprint and subsurface conditions, really understanding if you're going to have a structure, what are the requirements to set that up. So you have the approach, you have the tying conditions, really making sure that you have a firm and stable connection point from the pathway to the structures. And finally, allowing safety, durability, and life cycle comparisons of all options on the table, so you're ensuring that you have the most appropriate facility that you're using to cross these resources as possible. First, a brief overview of the various environmental resources, starting with water resources. Wetlands are areas where water covers the soil or is present either at the surface for all year or a period of time during the growing season. There's various types of wetlands, and they're regulated at the state level, federal level, or even some at the local level. Some have buffers, and some have various classifications depending on where you are within the country. So it's really important to understand what is a wetland, where are they, and I'll run through a couple examples here in a minute on the steps to going through the wetland process. Streams, so streams come in various categories, starting with perennial streams. This is a year-round stream where water flows year-round. Intermittent streams, they're seasonal streams where water flows basically just during certain times of the year. And ephemeral streams, basically rain-dependent streams, they only flow after a rain event, and runoff really is the primary source of water for these streams. Depending on where you are throughout the country, these have different implications for permitting and regulatory reviews. It's important to know what type of stream you may have and what the requirements may be to cross or to span a stream corridor. Finally, ponds and lakes. These are permanent water bodies with year-round water surfaces. Some have buffers, and it's important to know how these resources need to be approached during the plan design process. And finally, for each of these, floodplains could be in and around any of these resource areas or on their own. And it's important to know what are the possible implications of dealing with a flood zone or floodway and what the elevation requirements may be for each of those types of resource areas. So the first step when working around resources is to identify the map wetlands, streams, or water bodies within the project area. This starts usually at the GIS level, getting mapping, getting other known resources mapped into a digital means, and identifying where the possible trail or connection point is for users within the area. As you see here, there's multiple stream corridors that span the viewing area with different types of wetlands that were mapped by the NWI mapping system. Once they're mapped in the computer or brought in GIS, identifying potential buffers for each of the wetland or stream corridor areas. In this case, they're wetland buffers seen by the light hatching area around each of the resources. and really just getting a better idea as to what would be the requirements if we were to cross or go around any of these resource areas. So once you have mapping completed, it's always important to get boots on the ground and head out into flag, identify the actual resources in the field. And with that includes delineating wetlands or streams or floodplains and edges of ponds and lakes. As identifying the lower left-hand corner, flagging wetlands, following the local rules or your regional requirements by the Army Corps of Engineers or state is important to ensure that you're identifying the actual limits of the wetlands and then the potential buffers that would be associated with such wetlands. The example on the right-hand side shows a stream corridor that has a buffer highlighted in yellow, and just understanding what would be the potential impacts of creating a trail adjacent to the stream valley and within the buffer area. And finally, in the field, it's important to know what are the elevations of streams or other water bodies to know how would a storm event or rising stream waters impact a potential facility location, and what might be a strategy to address that while you're going through the design process. Forests and trees, these are regulated at various levels throughout the country, some cases at the state level or a local municipality level. But it's really important to know as you propose a facility through a forested area, where is the forest edge and where are the actual trees within the forest. So in the process, identifying the location as well as the species and sizes of each tree is really important. And not only does this tell you where you're dealing with the actual tree location is, but allows you to calculate what the critical root zone is. One example is critical root zone is 1 foot radius from the base of the tree for each inch of the diameter at breast height. So in this case, knowing where the actual tree is and what the critical root zone is around that tree is important to know if you could potentially be impacting a tree when proposing a trail facility adjacent to within the woods. So as you're looking at the trees in the forest, and identifying the species and the health condition of each tree is going to be important, because every tree handles impacts in differently. So the tolerances of the soil compaction or root severance is really important to knowing if it's going to be there in 10 years after a trail facility is proposed within a forest area. One example of this is looking at, for example, beech trees, which have a low tolerance to disturbance. You would obviously want to minimize any impacts adjacent to a beech tree or beech stand, while looking at some oaks have a moderate to good level of tolerance for dealing with impacts within the critical root zone. The International Society of Arboriculture is a great resource for looking at trees and identifying potential impacts and ways to mitigate impacts to trees within the forest. So with all this, next is establishing tree protection area and identifying how a trail or a trail facility could extend in and around the forest or adjacent to existing tree resources. In the field, this may be what it looks like, looking at each tree. The circles represent the possible critical root zones beneath each of these tree areas. The dashed line is possible trail alignment that residents have been using for a long time, and just understanding what are potential impacts of converting this from a goat path through the forest to a formal trail to connect between the residences. So understanding what this might actually look like long term would be to identify each of the trees, their current health conditions, identifying the critical root zone, and what is their tolerance for possibly impacting any of the roots and the areas adjacent to the trees within this forested area. So with all this, looking at all the resources, we step back and go back to a map and a plan and really map out all the resource areas. As illustrated in the plan on the top, the hatched area blue is the wetland area, so understanding what implications of extending a pathway through this wetland. The yellow dashed line is a buffer line that exists adjacent, parallel to the edge of the wetland. So understanding what are those permit implications for connecting in and through that buffer area. And finally, all the X's and O's are the potential trees that would be impacted by extending this pathway through this forested wetland area. So each of those, by looking at each individual tree, you can identify in the plan and in the field as to can a tree be preserved. In this case, we're proposing a boardwalk section, which would mitigate any impacts to the root zones. But simply as you propose a boardwalk through the wetlands, some trees would have to go just by means of the width of the boardwalk to connect across the project area.
And Daniel, can I chime in on say one thing here too?
Sure. Go ahead.
So this was an actual project down in Hillsborough County in Florida. As you can see, the designer, Cardno, elected to make the alignment a completely straight alignment. But what was important to that decision was the elimination of the trees. And not only did that drive how wide their boardwalk was in this particular example, but also the construction area. So this particular project was built with what they call top-down construction. So and I'll talk about this more in a few slides, but basically understand that top-down construction is where a structure or a boardwalk is built completely within the footprint of the boardwalk. So that allowed Cardno to minimize the damage to what they call swift mud, the water management district down there in Florida. They could have gone with a curved alignment, but the overall decision was to go with a straight alignment and force the contractor to build it via top-down construction.
Great. So as each of these projects continue, there is obviously a consideration for means and methods of how to actually build within sensitive areas. In each of these examples you see here, understand the context, the users, the approaches, and how to avoid environmental resource areas is critical to the success of a project. And as Jason mentioned, using different means of a top-down method where you minimize the footprint of disturbance within the resource areas, as well as identifying a place to pick a bridge, as in the lower left-hand corner, and place it across the stream corridor to minimize any impacts to the stream are critical to the success of any project. And that would simply come up in the permitting process and permitting strategy on how to illustrate that any impacts to resources will be minimized or avoided during the design and construction process. So with that, I'm going to hand it off to Jason, who's going to cover a little bit more about structure footprint and features within the trail corridor.
All right, thank you, Daniel. Just 1 second while I get things set up. As Daniel said, excuse me, as Daniel said earlier, Permatrack is a provider of a specific type of boardwalk material. We're not a designer, we're not a engineering company, we're not an architectural company, but what I am able to bring to the table is we're more or less considered a specialist. So we are working with designers like Weston and Sampson, probably many of the designers on this call. I know 2/3 of you were designers. So we work with designers when the need comes to the table to design a bridge or to design a boardwalk. And with that, I've been able to work with a lot of designers around the country, and we've seen some mistakes happen and some good and bad things. And that's where this list was generated, because as Daniel has gone through the first 2 items, I'll take you through the next 5. As a designer, for those in the room, the designers and the owners, be sure you're considering all 7 of these design considerations. So for example, number 3, the structure footprint. Just so that we're all talking about the same language, when I say the width of the structure, we're talking about what the clearance is between the railing, or in the image on the left, you see between the timber railing. That is what we would call the width of the structure. The span is is spanning from the abutment to abutment or from a pier support to a pier support. It may seem obvious to most people, but it's not always clearly understood by everybody. So thus we want to point it out here. And for example, as you design a trail, and now that you've decided you need to design a structure, so you have to decide how wide does the structure need to be. And the picture on the left was nothing more than a walkway to an observation platform at a National Wildlife Refuge Center in Maryland. And so there really wasn't a need to go extremely wide. And the decision was made, well, let's make this so that 2 or 3 people could walk comfortably along that walkway. And as you can see, for an 8-foot wide clearance on this particular one, 3 people easily could walk side by side out to the larger observation platform at the end. If you look in the background, you see some binoculars and a bench sitting on the platform. On the right-hand side, a different context. You see a couple of runners there. This is a greenway, and I would say this is very typical of owners and designers throughout the country, where they're looking to get maybe 2-way traffic, potentially cyclists going on both sides, maybe opposing sides. And you can see here, these were 2 runners, clearly had enough room. This is a 10-foot clearance between the railings. And I would say most designers or owners are designing towards maybe a 10 or a 12 and even 14-foot clearances now. There are definitely places in the country where we've been asked to design a boardwalk that is 14 feet wide, and the reason being is they want to run heavier vehicles, potentially emergency vehicles, ambulances on it. Sometimes the construction process drives how wide the boardwalk is. Not very often, but sometimes it will. But those are things to think about when you're trying to decide how wide does the boardwalk need to be. Another consideration is as you make the boardwalk wider, the load requirements are increased. And in the top right-hand corner, I've taken a section from the design code. And the design code for boardwalks is the LRFD Pedestrian Bridge Guide. And currently, there is not a section that will tell you how to design a boardwalk. There's not a section in the bridge guide that tells you how to design a boardwalk, or even in the building code. So the best design resource out there is the Pedestrian Bridge Guide. And if you look at the structures that are being designed, they are the closest fit to a pedestrian bridge. So you have to go to the Pedestrian Bridge Guide to get guidance on what are my design requirements. So from a structure standpoint, if you're a designer in the crowd, the design vehicle could be, for example, on the bottom right-hand corner, maybe all you want to run over this boardwalk is a maintenance vehicle or a small gator, and the image there may be a 2,000–3,000 pound vehicle. Most people think of running a gator, a small gator on the top of the boardwalk. However, from the design code, if the clearance on the boardwalk is between 7 and 10 feet, as you see in the chart, you're required to design for what they call an H5 truck. And simply put, an H5 truck is a 10,000 pound vehicular load. Many people think of, I equate that to say like a pickup truck with the back fully loaded with some material. And you can see how that load distribution is spread in that diagram. Also, if you go wider than 10 feet, logically, you should be thinking, well, I can run a bigger vehicle over the top. Well, the design code says you must design for heavier vehicles. Over 10 foot of clearance, you have to design for what they call an H10. And an H10 is a 20,000 pound vehicle. Those of you who design bridges may have heard the terminology HS20, and that takes you into the highway bridge design guideline. But most of the time, for the structures that Daniel and I are talking about, where you're going through wetlands or trails and greenways, an H5 or an H10 or a small maintenance vehicle is probably going to suffice. Concurrently to the design vehicle, you have to look at what the pedestrian loading is. And so you have to run both cases. You have to look at the design vehicle and then the pedestrian loading. The pedestrian loading for most structures is going to be 90 pounds per square foot. The building code in some regions will tell you have to do 100 pounds per square foot. Obviously, there are cases if the intent of the walkway is a stage or an amphitheater or a platform, those uniform loads, pedestrian uniform loads, will get higher than 90 or 100, and they could be 150 or even maybe 200 pounds per square foot. Also, there are regions in the country where we've designed boardwalks where there's significant snow load. We've designed structures out in Lake Tahoe, and there's certainly heavy design snow loads there, and they could be 100 or 120 pounds per square foot just in the snow load. So you have to compare that regional design requirement to what's in the LRFD pedestrian bridge guideline. We can't forget about thinking about how the boardwalk is going to be built. In the bottom right-hand corner, the left-hand side, you see a picture of what they call top-down construction. This is very common in wetlands because it minimizes the disturbance to the wetland environment. But think about the equipment that has to be put on top of the boardwalk. And you as a designer may not know that, but I would guess that your boardwalk designer would know that. We certainly know that at Permatrack. If you're designing a metal boardwalk, go to your metal boardwalk designer, your timber boardwalk designer, and ask them, you know, are we building this via top-down construction? Have you considered top-down construction loading? What you see in the picture there is a skid steer. That's probably an 8,000 to 10,000 pound piece of equipment. There's an excavator on the left-hand side. That particular loading put 30,000 pounds of loading on the structure. You have to design for that, simply put. The fourth design consideration is to consider what's going on below ground. And I would say this is one area where many owners, possibly many designers, look to possibly saving money. They say, the opinion is, well, let's eliminate that and let's do that later. Let's take that on further in the design process. I would advise that you take this on early in the design process, figure out with a geotechnical engineer's help, do that subsurface exploration. Go out there and hire somebody to do some soil borings where they actually drill down into the soil. They take soil samples, and then that geotechnical engineer can pull together design requirements. You know, is a driven pile a requirement, or is a helical pier the best suited situation, or possibly even a shallow foundation system? I've seen from my experience that a geotechnical engineering report could suffice for something on the order of, say, $2,000 to $5,000 most commonly. And many a times in our company, we offer to talk to the geotechnical engineer. If you, the designer, are not comfortable talking about loads and forces and piles and soil requirements, then get your boardwalk designer to talk to the geotechnical engineer. And we at Permatrack are certainly comfortable doing that with a concrete boardwalk. Number 5 is considering what goes on at the beginning and the ending point, or what we call the approach and the tie-in conditions. On the left-hand side, you see a very short pedestrian slash vehicular bridge on this one. This was about a 30-foot span crossing, and you can see that there's abutments on either end, and the trail that butts up to the abutment is a soft trail. It's nothing more than a gravel trail. So this is a soft condition approaching the abutment. So in that particular example, you would need to do a vertical back wall, some abutment at either side, so that the soft trail could be backed up to it and brought up right up to the top of that abutment. If that trail was a concrete trail, I would say that the abutment condition could be modified. You could eliminate the vertical back wall, and you could then take your concrete approach and you could turn it down and let it rest on top of that spread footing that would be supporting the bridge and the approach condition. On the right-hand side, you see a picture of a condition where this probably wasn't considered properly. The abutment was, in this particular example, was set too low. You typically are thinking about, when you're spanning streams, about spanning from bank to bank. And this one, the hydraulics really required the abutment to be at a higher elevation. There used to be a truss bridge on this particular example. The heavy storm events and the flooding that took place in this area scoured the backside of the abutment. I think the abutment was stable, but the trail behind it collapsed and caved in because of the scouring that was taking place on the backside of the abutment. So again, it's important to understand, are you dealing with a soft approach or a hard approach? How does that impact your decision on what the abutment should look like? The next design consideration is definitely safety. You have to, of course, you have to take into account the safety of the user. And as a professional engineer, that's my number one responsibility, is to keep the safety of the public and of the users of our system. So you have to be thinking about things like railing and decking and superstructure and the foundation. Of course, the foundation system has to be designed per code to a safe design, to a design code, but the railings are commonly something where the designer has to make a decision. And from the building codes, you will see that a railing is required when a structure such as a pedestrian bridge or a walkway is elevated 30 inches or more above the ground. On the right-hand side, obviously, there's a railing there because you're over a body of water. On the bottom left-hand corner, you see a tow rail or a kick rail because the boardwalk there was very low to the ground. So from a safety standpoint, they were not required to put a railing in place there. They could have, but from a code requirement, they're not required to. So you'll see tow rails or kick rails on the bottom. They're not required to do a tow rail or kick rail. They're not actually required to do anything, but commonly owners and designers like to put something there so that cyclists or walkers or strollers are not traveling too close to the edge. As you continue on thinking about the safety of the system, there's definitely many materials out there to consider. Obviously, there could be a metal structure, a metal boardwalk system. You could have timber and composite, or you could have a concrete platform. The metal boardwalk definitely has its advantages and disadvantages. For example, slip resistance of a metal grading system probably is not going to be highly rated. Durability certainly is going to be high on the durability scale. I see metal gratings being used often in areas where durability is important, as well as potentially sunlight passing through the system. There's definitely areas of the country where you're dealing with wetlands where the requirement is to have sunlight shining on what's going on below the boardwalk system. Timber and composite, I would say timber is going to be your most common boardwalk material. Obviously, probably most of you have been on a timber boardwalk. The aesthetics of that are probably the number one benefit for a timber or a composite. There are some you have a lot of choices in the composite market with the plastics and the different textures and the different colors. There's some very good, very pretty systems out there in the composite world. The timber system obviously is just a readily available material that you can go to Home Depot and Lowe's and get the material there. There are a lot of boardwalk designers and builders that have done this before, so it's generally top of mind. Generally, the first thing that designers are thinking of is to go to what they've done before, and they're very comfortable using timber boardwalks. The downside with the timber is the rideability and the slip resistance. As you know, it's going to be good early on in its design life, and over time it's going to get slippery, and the timber have a tendency to rot and twist and possibly decay over time. Durability generally gets a negative rating. The concrete boardwalk system, there are advantages to that. The concrete being that it's a formed either in place or precast boardwalk, can have a variety of different textures to it. Aesthetics, some would say negative, some would say positive, so I would say that could go both ways. The durability and the maintenance, obviously it's a durable product, being that it could last 75 years for a boardwalk system. Here's an example of some of the railing systems that I've seen on some boardwalks, and I'd like to point out here for the designers in the room that the railing can really make or break when you're designing a structure. You can go like in the top right-hand corner with a timber railing that could be going for say $40, $45, a linear footed railing, or you could put a stainless steel railing system on there that could be $300 a linear foot. And so the cost is choosing the material of the railing system is going to be very important. One thing to think about from a design requirement is the height. If you're in an area where you're expecting to have a lot of cyclists, you probably want to go with a 54-inch tall railing. The requirement would be that the shorter, if it's generally a pedestrian traveled area, a 42-inch tall railing is very common. I do see 48, and I've seen 54-inch tall railings in situations where the railing is elevated off the ground, or if there's a lot of cyclists in that particular area. And just some more examples of railing systems you see here. Again, the wooden and the steel I-beams you see there. Now be thinking about what goes on below the decking surface. The decking itself, we've talked about, but the substructure could be, it could be timber, it could be steel, or it could be glulam beams, or there could be, you could purchase a structure that's entirely prefabricated, like you see in the bottom two pictures. It's a truss bridge, and there's many companies out there that do that across the country, prefabricated truss bridges. But it's important to understand, if you're designing the structures, what the limitations of those materials are. For example, the wooden systems, if you're looking at that picture in the top left-hand corner, you see that the supports are generally close together. So be thinking about what that means to you as a designer or the owner. You're going to see more piers, and that I've commonly seen anywhere from 6 to 10 feet as you travel down the boardwalk, 6 to 10 feet of spacing between the piers. The concrete system, those can go up to 50 foot in clear span. Kind of the sweet spot for the concrete boardwalks are to keep them, say, 30, 20 feet in span. The steel I-beams, you can easily go 40, 50 feet with a steel I-beam, and then that takes you into some of these medium span, large span bridges. The metal trusses and the prefabricated trusses, you can get well over 100 feet with a prefabricated truss. Obviously, you wouldn't do probably a bridge of 100 foot or more out of wood. You would probably be looking at a prefabricated truss bridge. If you're in the ranges of, say, 10 to 20 or 30 feet, you probably could consider a glulam beam or a concrete substructure for that. Now, number 7, the last design requirements that I'd like to go over is to talk about the durability and the life cycle. And I put on the screen what I know. And what I know is about how a concrete boardwalk system compares to, say, a wooden boardwalk system. And I'm not trying to, run the Permatrack. This is not a sales pitch for Permatrack. I'm just illustrating to you what a life cycle cost analysis should consider. For example, these are numbers that were given to us from a designer, TGB, they're out of Texas. We did not generate these numbers. In the brown bars, you see what the wood boardwalk was originally costing, and then what the extended life cycle cost would be over the life of the duration that they considered here. And they found that it was 2.5 times the initial cost of the timber. The concrete boardwalk, in this case, the Permatrack, because of the low maintenance cost assigned to a concrete boardwalk system, was only 1.1 times that of the original selling price. And the maintenance that goes into, say, a timber boardwalk, as we said, was a negative, whereas those in the concrete boardwalk, potentially you may have to clean the boardwalk, whereas with a wooden or a composite boardwalk, you may have to pressure wash. Over a 10-year span, you may have to replace the boardwalk, and then that certainly runs up the maintenance costs that are associated with those. So this is just an example. Life cycle cost and durability certainly should be part of the equation as you're looking at your design considerations when you're designing structures through these areas. So we've covered a lot of information there. I'd like to go through now through some strategies, and Daniel will have a couple of slides here to chime in on also. And then on the last section, I'm going to show you some specific case studies that illustrate some of the things that Daniel and I were talking about throughout this presentation. So let's get going into this. For example, for bridges could be a very small structure like you see here. This is nothing more than a 16-foot clear span structure. This was a cross-country trail up in Ohio, and all they needed it for was something that was going to withstand the heavy flooding that was occasionally coming through this particular area in Dublin, Ohio. Bridges don't have to be small span. They could be long linear boardwalks like we've seen here. And this is an example for the Connecticut DOT where they wanted a very wide boardwalk. This was about a 14-foot clearance from railing to railing, and it had to take a winding path through the wetlands. And the designer of this particular example set the alignment of the boardwalk, set the elevation of the boardwalk, and set the clear width of the boardwalk, while the owner gave the design requirements for the boardwalk system on this particular one. Boardwalks could also be on a vertical or horizontal alignment like you see here. You see it may be hard to tell that there's a vertical alignment here, but it certainly is following that. It's following the natural ground line as you're going around the corners there. As a boardwalk design, you need to take into account what some of your existing field conditions are. This is one for the Massachusetts DOT where you see in the top right-hand corner there was an existing box culvert. The culvert had to swing to the left as you're looking at the picture and then curve back to the right. So there was this radius and safe radii to deal with in order to get the cyclist safely going through the box culvert that took them under a county road in Massachusetts. Culverts. Many of you are probably very familiar with what a culvert is. A culvert is generally a small hydraulic structure, small bridge condition. And you see in this picture some bottomless culverts applications. The shapes that you see there are some of the trademark images. There's some conspans, there's a Bebo shape, and there's a corrugated metal plate in the bottom left-hand corner. There's many suppliers of these systems throughout the country, but these are useful if you're having to take potentially a highway traffic over the top. And all of these examples are designed for, if you remember, I mentioned HS20 loading. So that's a 40,000 pound, 32,000, 40,000 pound design loading going over the top of the structure. But these bottomless culverts have become very popular because it allows the stream to naturally run from one end of the structure to the other, and in some cases, depending on the span of the culvert, the stream can even have a natural meander within the confines of the tunnel, because some of these get as large as 84, 102 foot in span from vertical wall to vertical wall. So there are many suppliers of this type of system here in the U.S.
So really quickly, beyond the structures that Jason's mentioning, by actually spanning some of the resource areas, there's a couple pavement options, alternate pavements that we suggest considering during a project. The first is FlexiPave. It's a porous pavement material that's composed of recycled tires and aggregates. It's applied monolithically, where it's basically placed down almost like asphalt, smooth surface. But what the advantage of this is that it will flex and bend and bow with any changing conditions below the pathway. For example, if there is a root condition where you're going to extend a pathway close to a tree or a forested area and you do not want to disturb the roots, this can possibly go down and allow you to place this over the tree area and not sever the roots or minimize impacts to the roots. It also allows some of the infiltration of water through the system, and in freeze-thaw conditions throughout the country allows the adjustment during these winter cycles. So another option is looking at gravel pave. There are several products on the market that are similar to this. Basically, it's a honeycomb plastic product that's laid down, and as you see in the graphic on the upper left-hand corner, it's filled with a washed gravel. So the voids are filled in, and what it does is allows water to infiltrate through this surface and into the ground, minimizing potential impacts to roots or the forest understory. These are pretty easy to install, lightweight materials, and also the advantages that they have a significant available loadings. So up to even fire trucks or buses could even pass over some of these systems if designed appropriately. There's another way that trails can be extended through resource areas without having to completely hollow out any of the existing trees or roots and resource areas within a corridor. Finally, a product that may be more familiar with many, as porous asphalt. So this is very similar to standard asphalt used on roadways, but instead of having a tight bind, it has more pores, more air voids, which allows water to infiltrate through the asphalt surface. The advantages of this are that it has same characteristics for users to run and walk on, and some even say it's better due to the voids when you're running, and less impact on the knees and legs. But what it does is allow water to infiltrate. So in some parts of the country, this is seen as a means for treating stormwater, or not the need for not having to have stormwater treatment facilities within some of these trail facilities. So it allows the trail to connect through resource areas, and while also allowing stormwater to either be collected or to be handled within the actual footprint of the project. So with each of these alternate pavement options, it's really important to know who the users are, the context, the permit requirements or regulations that are driving some of the greater context of the facility. So having a strategy to design and plan trails and through resources is really critical from day one.
All right, thank you, Daniel. So now I'd like to go through some case studies to show you specific examples that have been constructed throughout the United States, where some of the design considerations that were mentioned were brought to the table as being the #1 consideration for, and in some cases, the reason for the structure. So I'd like to go through those with you before we wrap up the seminar after the 4th case study. So case study #1 has to do with wetland construction, and I've mentioned to you, and Daniel has, about the importance of minimizing the disturbance to the wetlands. And this is an example for the town of Glastonbury, Connecticut. This was a multi-use trail, and you're looking at the footprint of a boardwalk system that has a horizontal alignment to it, some horizontal curves to it, and it also had a vertical alignment to it. And the approaching trail reached the wetland, and you can see from here that there's some contours to deal with. So this is an elevated situation where they had to consider safety with the railing itself. And they had to take into consideration how was this boardwalk going to be built. And they did this by what they call top-down construction. Now, this was the piers that you see in the image here. They were concrete piers. They were augured. Holes were augured into the ground, and they used sonotubes to form the piers. And the piers were spaced every 10 feet or so along the alignment of the boardwalk. And I would call this a half top-down construction. The piers that are in the image were built from the ground, but they built that from between the piers. So imagine a construction equipment operating between the piers. So the piers were spaced far enough apart where the drill rig could operate between the piers. Once the piers were built, the regulators did not require the installer to be traveling up and down and continuing to damage the wetlands. And they did that by top-down construction. You can see from the picture, they used, this particular installer chose to use a mini tractor. Product was delivered by the tractor, and then an excavator then reached out and set the product in front of them as they went. And it's not always small pieces of equipment like this. It sometimes can be larger pieces of equipment. Again, the boardwalk itself has to be designed to withstand those construction vehicles. And this is what the finished product looked like. You've seen this picture once before. A 10-foot clearance between the railings with a horizontal and a vertical alignment. And this was what you're looking at is about 150 linear feet of boardwalk through this wetland area. Case study #2 has to do with durability. And there was a town in New York, it's called Croton-on-Hudson. And not only did they have, excuse me, the durability, so we're talking about durability and heavy loading. Let me start over. This particular example is in Cheshire, Connecticut. And this is a structure that was designed by the Connecticut Transportation. And part of the requirements for this structure was that it had to be made of a material that could withstand the severe winters that they experienced in in Connecticut, the colder climates, as well as they had a heavy design requirement on this one. The requirement was that they wanted to be able to run an ambulance over the top of the boardwalk. In this case, it was a 30,000-pound vehicle that was provided to the designer, us, on this particular example. So a lot of the components had to be custom sized because of the heavy loading. Again, could they have designed this out of timber? Probably, but it would have been, it certainly wouldn't have had the durability. It wouldn't have had the, it would have been difficult to design a boardwalk with that type of material for such a heavy design loading. So the designer, which was actually the Connecticut Department of Transportation, they designed the system, and then Permatrack then came in during the bidding phase and provided the specific design of what met the design requirements from the Department of Transportation. And we see specific loadings come up. It may not be a loading from a designer, maybe it's an ambulance, for example. That could be a specific requirement, or maybe a snow blower. That comes up a lot also. Example number 3 is one that illustrates the user safety. And I hope this image kind of captures what's going on. You see in the top left-hand corner, there's a yacht club or a marina up on the top left-hand side. And down on the bottom part of the image, you'll see a park. And so there's a body of water on the left-hand side, and there's a highway expressway on the right-hand side, and then there's a railroad between the water and the highway. That left a very small stretch of pavement for traffic and people to walk if they wanted to go from the yacht club to the park. So from a safety standpoint, the town was very concerned about pedestrians walking from the yacht club to the park, because this park was a very popular park, especially in the summer months. They have a lot of concerts and summer events, and they needed a boardwalk that could more or less hang over the side of the road. There was not enough room to simply pour a sidewalk on grade without some serious modifications being done to the Hudson Bay, which is right there in the image. So this is what they ended up with in this particular case. You see the road on the right-hand side, the body of water on the left. The boardwalk was, in essence, built on the slope of the water, and it was cantilevering itself out over the water. And the designer specifically wanted to minimize how close they were to the body of water, but yet they needed a safe travel walkway for pedestrians to get from the yacht club to the park. And they did that by designing a system here. It may look odd to you that the deck planks, or what we call the treads, are hanging over the edge on the left-hand side. Those are purposely being done that way. They were structurally designed that way. The designer wanted the users to not only have enough travel space, but they wanted to be able to stand and look over the water. And then in the summer months, to be able to turn their heads and look at the fireworks and listen to music that was taking place in the park. So again, user safety, this eliminated the pedestrians from walking alongside the road, which created a very, very unsafe condition on this particular example. So here's a look in a little bit warmer climate, looking towards the park, and they dressed this up with a cable railing with a steel post system on this particular example here. And the last example I'd like to mention before I turn this back over to Candace and the questions is one of avoiding the critical root zone. Remember, Daniel talked about how to determine what the critical root zone is and what are you allowed to do in those particular areas. And this designer wanted to put a walkway system in what they call an upland wetland area. And the rules for this particular job were that they couldn't penetrate the ground more than 2 feet. And a system of a boardwalk system like our system was used here, where the foundation system simply rests on top of the soil, and it could be moved in by hand. So the piers that you see there were set by hand. All of the components were set either by hand or by very small lifting equipment. This was all built from the top down on this example. And similarly, here's another example in Charleston, South Carolina. You can see the very pretty tree on the left-hand side, and you can see the roots that are extending up and under the boardwalk system here. The rules were that you couldn't simply just pave a sidewalk up over the root system. It was that wasn't going to be allowed. It wasn't going to be allowed to drive a pile or cut the root system and pour a footing. That wasn't allowed. It had to be something that could rest on the ground. So an arborist was involved to determine where the absolute do not disturb areas were, and guidance was provided by him and the designer of where the piers could be. And then a flexible system like what you see here was designed on this particular example here. So we've said a lot. So at this point, I'm going to turn it over to Candace. I think she may have some questions that are showing up, and I'll let her continue from this point on.
Thank you so much, Daniel and Jason. Really appreciate the presentation. And it looks like you guys should be able to see my screen now. So you'll note that we do have a variety of links that were provided to me by the presenters. There are a few more on the web page, the very first link at the top that you see. And just so you know, it is the same webinar. It's what it was titled at our conference, at the International Trail Symposium, and we ended up changing the title slightly for the webinar. So it is the correct one, then, just in case anyone's wondering. But yeah, you don't have to rush to write all these down either, because I will be sending this slide as well as the next slide that I will show with all of the presenters' contact information, and their websites, and just some more great resources I'll include with the link to the recording and the closed caption transcript. So I'm going to go ahead and get started with the Q&A. We only have a handful of questions, so I invite anyone who's on the line to send us their questions. And again, if we don't get to all of them during the live presentation, I will be working with the presenters following the webinar, and we will add all of the Q&A online within a few weeks. So I'm going to go ahead and get started with the first question. Heather asks, to install a trail where there are roots, can you install more soil to save the tree?
I'll take a first stab at that, but that's a great question, Heather. There is a misnomer, I think, in the general design profession that just simply adding more soil would help with the roots and saving the tree, when actually it could actually do more harm. The idea of just compressing or actually removing the possible infiltration of water and air into soil root zone area is actually not a bad thing. It's not a good thing to do. So what we would recommend is, when looking at the tree, getting the correct root zone, identifying the health of it, and also the tolerance level of the tree to having any impacts, and also identifying how much impact would be possible or anticipated when doing a trail near a tree or forested area. Then determine if any amendments could be provided that would allow you to cover over some of the roots, or if some of the roots were sacrificed to allow the trail to extend adjacent to the tree, would be the first step. There are various means and methods, whether it's from aerating the root zone or to supplementing with other materials on top or around the roots, will be a secondary action after identifying the potential impacts to the tree itself.
Thank you so much, Daniel. Francisco has a question about porous asphalt. What are the maintenance issues?
Yeah, so maintenance issues. So with porous asphalt, with any type of facility, whether it's a boardwalk, a bridge, or porous asphalt, maintenance is certainly something really to consider. So with porous asphalt, depending on where you are throughout the country, in the Northeast, where you may have a pathway that gets sanded and gets significant sediment loading, you have to either vac it out, or I've heard of possibly pressure washing it with a pre-cement piece of cement, washing out the pores. But really, it's knowing what are the the sedimentation that's happening within the porous areas, and making sure that you keep those pores open. So it kind of depends on where you are and how it's being impacted, but that could be a decent cost if you end up having to do it annually or even more often, depending on what the loading is nearby to the porous asphalt area.
Kayla asks, and this might be directed, I think, to Jason, can you share the cost of the case study examples?
Yeah, so I assume you're talking about the life cycle cost comparison. Absolutely, I can send that in a separate email. Absolutely.
That would be great. Thank you. I'll definitely make, I can include that as a follow-up in my follow-up email to attendees as well, just depending on when I get that. So thank you for asking that question, Kayla. Ryan asks, how is resistance to salt, acid, rain, etc. for concrete? How long are the textured finishes anticipated to last?
Yeah, I can answer that question. So those are good questions. Those, you know, the durability of concrete is certainly something that is unquestioned. I mean, it's something that's 50 to 75 years. But as we apply a texture to the top surface, and that's done in the plant. So the pieces are precast, and there's a textured surface on the top. What I can tell you is that we have structures that are now going on 22 years, and I have stepped on those structures that now they exist over in Australia. The older ones are in Australia. The texture looks very good. There's been zero maintenance done to the texture itself. In the United States, the oldest structure that we can attest to is 10 years old, and I've been on those also, and they're doing very well. You know, the one thing I notice more so is that they just get dirty. We do have a texture that is sandblast texture, and some of the peaks of the sandblast texture would get more rounded, but generally they do very well. Over 10 years, I've been quite impressed on the ones that I've been on of how they are lasting. So hopefully that answers your question.
Great, thank you. And then just to add on to Kayla's question, which again, I can even follow up with you on this, Jason. She would like to know the square footage construction cost of those case studies.
Yes, we have that. We do have that specific information. That'll be part of the summary.
Perfect. Okay. Christine asks another question for Jason. How do you anchor the surface pier blocks to avoid shaking when in an earthquake?
Oh, very good question. Yeah, that's a very great question. I didn't mention about seismic loadings, or to extend it even further, just any uplift conditions. Our specific system is not always connected vertically or mechanically. If you're in a situation like on the West Coast or maybe some of the high seismic zones, we would use a mechanical fastener, which could be something like a clip angle that could be secured underneath the system. It generally is going to be hidden under the boardwalk. The system, as it sits on top of the pier, would be connected with a dowel or a drill and epoxy bar. It could be attaching the beams to the piers. If the pier system is a steel pile or maybe a helical pier system, then maybe the connection is a threaded bar that would pass through a bearing plate condition, and there would be a threaded bolt that would be bolted to the foundation system. So there's a few different ways on how to do that. Seismic generally requires that all the pieces be connected. In a floodplain where the system is going to be underwater a lot, or maybe a storm event completely inundates the system, then maybe not every component needs to be tied together. Maybe just a series of them would be tied together. And I say not every piece because in our specific system, the panels themselves interlock. So that's simply unique to our system. They interlock, and so that eliminates the need to tie every piece down to the piece below it.
Great, thank you. Brandy asks, For bridges spanning streams, can abutments be placed on top of the stream banks, or must there be excavation/foundation into the soil?
Wow, that's a very good question. I don't know that I know the answer specifically to that. It is going to be case sensitive. If you remember the example I showed you where the abutment was right on the edge of the abutments, right on the edge of the bank. So that is a bank-to-bank application. That abutment could have been pulled further back away from the top of the bank. Probably would have seen less scour. But that abutment very well could have been in the stream. However, you'd have to take into account what are the scour implications of an abutment being in the stream. If the abutment is in the stream, then you are, necking down or narrowing the passageway hydraulically. I would say in the larger streams, you're probably not going to be allowed to do that. If this is a small low flow swale crossing, you probably have the flexibility of maybe narrowing the channel. So again, I'm sorry, I probably need to know more specifics about your example about whether or not an abutment could be placed in the stream. Generally, when there's a foundation component in the stream, it would be referred to as a pier. So you would be a multi-span, and you would be spanning from the bank to a pier to the bank. So again, I would probably, if I had more specific information, I could answer that maybe a little better for that person.
Thank you. Brendan asks, for bridges with widths smaller than 7 feet, what are the vehicle weight ratings, and where does one find those limits? Are those national standards?
I'm not aware of any national standard codes. No, there's the design code simply says that you have to look at a 90 pounds per square foot pedestrian loading. Vehicular loading would be specific to whatever the use is. Generally, I've heard that users just want to run a maintenance vehicle over the top. There are no design codes that define exactly what a maintenance vehicle is. So obviously the next question is, okay, Mr. and Mrs. Owner, what is your maintenance vehicle? What does it look like? Generally the answer is, oh, it's just a small gator, it's a golf cart, it's something like that. And then those can be easily found on the website. We found that generally 5,000 pounds would cover most maintenance vehicles. Now, the question was written load ratings. I'm assuming you're meaning what are the values of the load itself, not a true load rating. A true load rating would be to determine the capacities of the structure for different load weights, and that would be specific to the material of the system. So if you're looking for defining what a maintenance vehicle is, you simply would have to ask the owner, what is it that they typically use? There's nothing in a building code or a design code that will tell you what exactly that is.
Thank you. Okay, Barrett asks, how well does FlexiPave hold up in a winter climate such as Minnesota and the Dakotas?
I could say from not having worked in Minnesota or Dakotas, the Northeast, it has worked pretty well. Obviously, the more that the pavement is going to heave and settle, it's going to wear in time. I have seen cases where it has cracked in some cases, but going back and repairing this material is actually pretty easy. So not having experience in Minnesota or Dakota specifically, I can't speak to how it would handle that harsh climate, winter conditions. But I think probably FlexiPave would be happy to answer that for you if they have installed that product in your neck of the woods.
All right, Charlie asks, please address the pros and cons of composite timber.
Oh, wow. I'd love to take a stab at that. So pros and cons of a composite and timber. We'll start with timber because that's the most common material of choice. The pros for timber certainly are that they're readily available. The material itself, just the material, is generally going to be the cheapest one on the market. Most commonly, you would see a southern yellow pine. Some of the timber material, timber material, maybe like the ipe or the dense hardwood. That is a more durable type of wooden product. Advantage of a wood is that it would be you know, it would have the aesthetic appeal that the wood has, and it would last longer than the timber. So those are a couple of items there. The downside on the timber is that, first of all, it can be very slippery. The composites can be very slippery. The wooden boardwalks generally, especially in the moist climates or the harsh climates, are going to curl and rot and twist and decay, and then the fasteners could unravel and pop, and that just requires maintenance. So generally with a timber boardwalk, you're going to see much higher maintenance costs. Life of the structure on a timber boardwalk, I've seen anywhere from some of the coastal areas to last only 4 or 5 years, to say 15 years would be 10 to 15 would be a very average lifespan for a timber boardwalk. If you're getting more than that, I'd say you're doing quite well. We have been called in to replace boardwalks as long as 1,000 feet that have been in the ground for 8 or 9 years, and they have chosen to replace it because of the reasons I just gave. The composites generally are chosen because they are aesthetically pleasing. There are some very good-looking composites out there. There's a whole variety of composites out there. You probably have heard of Trex. There's Timbersil. There's some others out there that are, you know, you can get a lot of shades of browns and different colors that are very, very nice, and you'll see those. Now, generally, those are used for the lighter loaded applications. So if you remember the applications where we were talking about running a 10,000, 20,000 pound vehicle over the top, you're probably going to have a very hard time designing a boardwalk with a composite a decking material. So that'd be very, very difficult to do. So you'd have to go with a hardier product, maybe the hardwoods, maybe you go with a metal boardwalk, or of course you could go with a concrete boardwalk system.
Thank you, Jason. Leslie asks, any thoughts on addressing anticipated changes to hydrology over time due to climate change in planning and design of boardwalks?
I'll take a stab at that. We're seeing, obviously, climate change happening on more and more projects these days, and the planning and design of boardwalks obviously fits into that spectrum when we're dealing with a lot of trail networks and connectivity projects. The overall sense is it's important to know earlier in the process to what is the projected hydrology elevation change or severity of storm events. So in case of a boardwalk area being flooded, it comes down to what is the timeline that flood event would happen? Is in 10, 20, 30 years, that the water levels will rise? And then it's also the consideration of what is the tolerance of the client or the municipality to withstand having that feature be inundated and for periods of time eventually be underwater or have to be modified to account for the sea level change or climate change. We have some locations where we are projecting boardwalk systems that are higher than what would be the historical standard for elevations off of the ground, just because we know that in some locations the climate's changing and we anticipate that the elevations will be higher, but eventually, say in 30 years, it may be inundated completely due to the water body that's adjacent. It also has been influencing some of our decisions on material choice. So going towards more durable products that can withstand more severe events in the case of concrete, or some metal products, as Jason mentioned, for some of the prefabricated bridges. Those then have a greater value when we're evaluating using wood, concrete, or steel products within a project. And then, long story, it comes down to costs. Are the funds available to make these changes now? Is it long-term possible that the structures could be raised or could be modified when the need is truly there, or if the funds do come forward to make those changes? So it's a many multifaceted issue we are faced with on main projects, but it a lot of times comes down to, can you spend the money up front now to accommodate for this change in the climate.
Thank you, Daniel. Looks like we have time. We'll answer a couple more questions. Kathy asks, in planning trails through natural areas, how do you incorporate native cultural components?
So I'll take a step at that, but I think what you're asking about is if you have a cultural resource or archaeology or another historic resource within a trail corridor, how do you incorporate that into your planning and design process? A lot of times, it comes down to what are the resources that you are looking to account for. Is it simply a site or a feature that could be preserved or retained, possibly restored, to then be amenity along the trail or within the corridor project area? There's cases where providing interpretation signs that might show an image of what the resource was at one time. For example, if it's a foundation that exists, showing a rendering of what the house or structure once was that was within the trail corridor has been beneficial. And that's honestly, sometimes that has opened up doors for possible funding sources for various municipalities, saying we can get funding to support historic preservation or cultural resource preservation on our projects, and that's helped support the overall cause of the project. So avoiding minimizing any impacts to resources is important, but also illustrating or educating users within a trail has been beneficial on many projects.
Thank you. All right, last question we have, or at least for the live webinar. Brandy asks, should wildlife passage be a consideration when determining spans of bridges and heights of boardwalks?
Yeah, you know, I have a little bit of experience with that. And should it be considered? Absolutely, it should be considered. And there's definitely been cases in my professional experience where the structure size and length was determined for exactly that case. And I'd be glad to send you examples, images of structures that have been designed for that. But of course, it's a case-by-case situation. Generally, the boardwalks are going through, through wetlands. But if there's some known habitat that needs some certain clearances vertically or horizontally, there could be, I remember some turtle crossings where the boardwalks had to be elevated to pass over these areas where the turtles would be. And there's definitely there was a one out west for the black bear. I think they wanted to be able to have the black bear pass over the top of the structure. So those things definitely come into play in the design of the structure. I would say from my viewpoint, we're just part of the solution. We can explain what we can or can't do, and designers like Daniel would know possibly what fits the site better, being more local. So between Daniel and us, if it was on our project, we would evaluate that and we'd make the decision as to whether or not it's a requirement. Is it a need or is it a want? And then of course it has to be affordable at the end of the project, however the design comes out.
Well, thank you so much. Again, thank you, both Daniel and Jason, and thank you so much to everyone who attended today's webinar. And again, I want to thank all of the partners of today's webinar that include the U.S. Department of Transportation, Federal Highway Administration, the National Park Service, U.S. Fish and Wildlife Service, the U.S. Forest Service, as well as the Bureau of Land Management. And we hope you'll be able to join us for future webinars offered in our Advancing Trails webinar series. Our next webinar takes place on July 18th and discusses social media and the impact it has on trails. Keep in mind that this is a working title and this may change just in case you are interested in this upcoming webinar, but social media will definitely be the main topic for that one. And just so you know, we will be hearing from a few presenters for that webinar that have had some great success stories when it comes to promoting their trails and organization using social media platforms. A reminder that our webinars are $19 for members or $39 for non-members, and do include learning credits via the American Planning Association, American Society of Landscape Architects, and CEU equivalency petition via the National Recreation Park Association. Again, thank you for attending. attending. Thank you again to our presenters and partners for this webinar. I hope you all enjoy the rest of your day and happy trails.